so yesterday we looked at lesson 14 and lesson 15. We talked about multiplying decimals by whole numbers, alright? Alright, can somebody tell me something they remember about multiplying decimals by whole numbers? Let's start with an example. If I wanted to multiply 6 times 22 hundredths, what do you remember about how am I putting it? Give me an example or model of how you could solve this problem. Lindsay. Line them up vertically? Yeah. So what would you put?
0.22.
Huh?
0.22
0.22 times 6. And then what? Then multiply it out. So 6 times 2 is 12. 2 carry the 1. 6 times 2 is 12 plus 1 more 13. And then 6 times 0 is 0 plus the 1. So you can tell me, what do you think? Where does our decimal go? After what? The 1 right here. Why do you think it goes there? Remember I told y'all for multiplying decimals, you don't necessarily have to line up the decimal. You just have to remember the value of what you're multiplying, right? So this right here would be 22 what? Hundredths multiplied by what? 6 ones. And we know that anytime we multiply something by ones, we end up with what we already have. So I know that my unit is going to end up with what? Hundreds, because hundreds times ones are hundreds, right? And we can still just go in and multiply it out, just remembering where our place value has to end. 6 times 2, 12. 6 times 2, plus 1 more, 13. And remember that this is 132 hundredths, which means that that last digit has to be in the hundreds place. So that means my answer is 1 and 32 hundredths, right? Now, this way, I don't want y'all to do it this way, because when I'm multiplying decimals by decimals, it does not end up like that. I don't just line up the decimal and then just put 2 behind it, okay? We're going to get to learning exactly what that means later on throughout this, right? Alright, so another example was multiplying. Yesterday we also talked about multiplying 2-digit numbers, or was it multiples of 10, 100, and 1,000 by decimals, right? So if I wanted to multiply 700 times 1 and 53 hundredths, right? 1 and 53 hundredths. Who remembers a way we could solve this problem? Akira? An area model? We don't really talk about the area model for these. Huh? Not the distributive property, it's a different property. Associative property, right? So we remember the associative property tells us that I can break these numbers up into their what? Not their parts, they what? Somebody said factors, right? So instead of looking at this as 700, I can look at this as what? 7 times 100 times 1 and 53 hundredths, right? Do I have to multiply 7 by 100 first? Does it matter which order I multiply these in? No, as long as I don't do it. As long as I multiply all 3 of these factors, right? So can I multiply 100 times 1 and 53 hundredths first?
Yeah.
What happens to a number when you multiply by 100?
It goes high.
Huh?
It
shifts its place value
twice.
how many times?
Twice.
In which direction?
Left.
So that means instead of this 1 being in the ones place, it's going to take 2 shifts and end up where? In the hundreds place. The 1 will be in the hundreds place. That 5 will end up in the tens place, and the 3 will end up in the ones place. And I still have to multiply this by what? 7, right? And so now off to the side, I can write 153 times 7, and that's a normal multiplication problem, right? 7 times 3 is 21. 7 times 5 plus 2. 7 times 1 plus the 3. 10, right? And I know that my answer is going to be 1,071. Now let's take a minute and think about what we have here, right? So I want you to think of scaling factor that we talked about when we were multiplying fractions, right? If I multiply a number by a fraction that is greater than 1, am I going to end up with something greater than or less than that number I started with? I said a number greater than 1. I'm going to end up with something greater, right? So let's look at this decimal that we're multiplying. Is that greater than 1 or less than 1? Greater than 1. So that means that my product should be greater than what? 700. Is my product greater than 700? Yes. So is this answer reasonable? Yes. If I accidentally did this, multiplying it out with a fraction, and I decided, well, I'm going to go ahead and put 2 digits behind the decimal place, all right? Is that 10 and 71/100? Is that a reasonable answer? No, right? I started with 700, and I'm multiplying by something that is greater than 1. So my product should be greater than that 700 I started with. We understand that? So if I multiply this 700 by something less than 1, that means my product is going to be what? Less than what I started with. Less than that 700 I started with. Alright? Alright. So today we are going to branch a little bit further into that exact same topic, just moving into multiplying different numbers. Alright? So yesterday we talked about multiples of 10, 100, 1,000 times decimal. Today we're looking at 2-digit, 3-digit numbers. Not necessarily multiples of 10, 100, and 1,000. Alright, so I need you to open your workbooks to page 151. 151, right? Alright, so on this page we see use the area model to find the product, right? And the area model is just like using the area model with normal multiplication. We just got to think about what? The value of the decimal, all right? So here, if we look, we have 41 being broken up into what? 40 and 1. And then at the top it says blank tenths. You see that? It says blank tenths. What goes there? 2. Just the number 2. Right? So this is just taking this decimal that they give us and putting it in, what's that form called? Decimal, not decimal form. Unit form. Put it in what? Unit form. So I'm going to just put that 2 there. And I have to remember that whatever I'm multiplying that 2 by, I'm multiplying it by the tenths, right? So what is being multiplied in this top box? 1 times what? 2 tenths. And what is 1 times 2 tenths? 2 tenths. How do I write 2 tenths as a number? 0.2. Right? And what about here? I'm multiplying what? 40 times 2 tenths. What's 40 times 2 tenths? What's 40 times 2? 80. But that's 80 what? What's 80 tenths? 8 ones, right? 80 tenths, if I wrote it as a fraction, it would be 80 over 10, and we know that equals to what? 8 ones. What do I do with these 2 pieces here? Add them together. What's 8 plus 2 tenths? 8 wholes, or 8 ones, and 2 tenths is 8 and 2 tenths. So that means 41 times 2 tenths gets me 8 and 2 tenths. We're going to do another practice. So let's look at number 2 based off of what we just did on number 1. So once again, we have 41, but this time it's multiplied by what? 23 hundredths, right? 23 hundredths, right? So what am I putting in these 2 boxes, these 2 lines over here? 2 tenths and 3 hundredths. Remember, we have to pay attention to the value of that decimal that we multiply, all right? Here, what is being multiplied?
1 and 2 tenths.
1 multiplied by 2 tenths, which equals what? 2 tenths, which is the number 0.2. You understand that? What's being multiplied here? 1 times 3 hundredths, which equals what? And how do I write that as a number? 0.03. Alright? What's been multiplied here? 40 times 2 tenths, which equals what? 80 tenths, or the number what? 8. And then this last spot, I'm multiplying what? 40 times 3 hundredths, which equals what? 120 hundredths. What is 120 hundredths as a number? 1.20. The last digit, that 0, has to end up where? In the hundreds place. So that's 1.20. So now what do I do with all these pieces? Add them all together. I have 0.2. I have 0.03. I have 8. I have 1 and 2, 0. I'm gonna leave it like that?
No.
What can we add here? What I need to put in there? Some place values, right? I mean some placeholders, right? Does that change the value of any of those numbers? No. So we got 0, 3, 0, 0, which is 3. 2, 0, 0, and 2, which is
4.
8 and 1, which is
9.
So that means my answer is going to be 9 and 4,300. So up at the top, make sure you go back and write 9 and 4,300. Anybody have a question about this process right here? Alright, I do know that this part right here may get confusing. Where you have 40 times 3, we know that's 120. But that's 120 hundredths. Please remember that when we write that as 120 hundredths, we have to remember that that last digit, that 0 right there, has to end up in the hundreds place. Alright? So taking it from unit form to actual standard form may be an issue to us sometimes. Please pay attention to it. Alright, so I do want to look at number 4. Let's look at number 4. So we'll skip over number 3 for a minute. Let's look at number 4. We are going to look at this the vertical way as well, y'all. Alright, number 4 says 32 times 4 and 61 hundredths, right? 4 and 61 hundredths. So what I'm going to put at the top of this box? 4 ones, 6 tenths, and 100. Alright. Alright, so what's being multiplied in that first box?
2 times 4 ones.
2 times 4 ones, which equals?
6.
What?
6.
2 times 4?
8.
8. And those are what? 1. So we can leave that as just the number 8. What about this next one? 2 times 6 tenths, right? Which is what? What's 2 times 6? 12, but this is 12 tenths. How do I write 12 tenths as a number? 1.2. So I know that this equals 1.2. So that is 12 tenths. This next one should be 2 times 100, which equals 200. How do I write that as a number? 0.02. Exactly. So we got that first row done. Next I can move down to the bottom, right? What needs to be in that first box?
30 times 4.
30 times 4 ones, which equals 30, 60, 90, 120. That's 120 ones, which is just the number 120. The next one, 30 times 6 tenths, which equals, what's 30 times 6? 180, but this is 180 tenths, which is the number? Those are hundreds. If this equals 180 tenths, what digit has to be in the tenths place? That's 0. The last digit has to be in the tens place. So this is what? 18.0. That's it. Because that last digit has to be in the tens place. This is what I was talking about. Taking that unit form and changing it into standard form. We good? Alright, in the last box.
30 times 100.
Which equals? It equals what? It equals what? 30 hundredths. And as a in standard form that is. Say what? 0.30. Because what has to end in the hundreds place? That last digit. We understand that, right? This last digit has to end in the hundreds place. So that is 0.30. That 0 is in the hundreds place. Ones, tenths, hundreds. Now what's next? Add it all up. Now, I got 8, so I'm going to write 8.00. My next number is 1.2. I'm going to put a 0 at the end of it. Is that going to change anything? No. My next one, 0.20. My next one, 120. That 0 needs to be in what place value? This 0. The ones place. Do not shift that all the way over here. That 0 needs to be here. And then I'm going to add a decimal and what? 2 zeros. Does it change the value? No. What's next? 18. That 8 needs to be where? In the ones place. Please line these up in the correct place value. And then the last set is 0.30. And remember, when we add decimals, we have to line up what? The decimal. Put the ones with the ones, the tens with the tens, hundreds with the hundreds, tenths with tenths, hundreds with hundreds, so on and so on, okay? Okay? Alright, looking at this. All these are what? Zeros. And I got 3 plus 2 plus 2 more. 7. 3, 4, 5, 6, 7. Now here I got 8 and 8, which is 16, plus 1 more, which is 17. 7, carry the 1, 2, 3, 4. And 1 in the hundreds. What happened? I forgot what? Oh. Well. Oh, y'all right. Somebody got it. I did. That's great. So now instead of this being 0, it has to be 2. And instead of this being 7, it has to be 5. Great. So that means the answer should be what? 147 and 52 hundredths. Questions? Somebody better ask a question. Because we about to move off the area model, we about to move to the vertical way. Standard algorithm. Let's just add. Yeah. Wait. What's your question? What you just asked me? Like that 120? That's why I said make sure that 0 ended up in the ones place. When I wrote it over here, I added what? A decimal and 2 zeros, just to make sure all of my stuff lined up. Please do not shift all of these numbers to the right or the left. Make sure that you are lining up the decimal and you're adding ones with ones and not with hundreds. Okay? If you have to, you can write all of them in the same format when you write these out. So since I know that my answer ends in the hundreds place, right? Since I see my answer ends in the hundreds place, I can go in and make sure that each one of my answers over here end in what? The hundreds place. I can add that decimal and 2 zeros. I can add a 0 here. I can add a decimal and 2 zeros. I can add a 0 here. And that way when I go to add them up, I already have them all ending in the same place value. Okay?
Gotcha.
Does the decimal or the zeros change the value of those numbers? No. Any questions? Alright, so the back page of my workbook got a whole bunch of green on it, so I'm going to write it on white paper. So that first one, looking at number 5, what is that problem? It says find partial products, then add to find the product. What does that first one say? 26, 3 and 4 tenths. Alright, and the way we talk about this is, so the way they have it set up, they changed this to be what? 34 what? What did they write in the box? 10s multiplied by 26. Right? And we know that our answer has to end up in the what? Tens. So let's take a pause for a second. Let's look at each one of these answers that we just talked about, right? In these problems, how many digits were behind decimals in this problem? 1. And how many digits are behind the decimal in my product? 1. What about this one? 2 and 2. What about this one? 2 and 2. Now when we get to multiplying decimals by decimals, you're going to have to count all the digits that are behind the decimal. And make sure that your product also has the same number combined behind the decimal. Okay? Because if I'm multiplying tenths by hundreds, my answer is going to end up in the thousands. Which means I should have 3 digits in all behind the decimal. But that's not right now. Right now we're still working on whole numbers multiplied by decimals. Alright, so once we have changed this number with the decimal into its unit form, I can just go straight and do it. Multiply it out. 6 times 4 is 4. Get rid of 2. 6 times 3, 18 plus 2 more, 20. Scratch that out and move to the next one. 2. Alright, what I need to remind myself? Placeholder. Do not forget that when I move to the next place value, I need to add a 0 as my placeholder because I'm now multiplying in another place value. This 2 by the 4 is 8. And 2 times 3 is 6. Now what's next? Add our partial products. 4 and 0. 8 and 0. 6 and 2. 8. And I have to remember that these are tens. Tens. Which means that is my answer 884? No. No, what's my answer? 884. What? What? If this says 884 tenths, that means that last digit has to end up in the tens place. So how do I write this as a decimal form? And 4 tenths. That's it. Do I need to write the word tenths back here? No. No, because I already changed it into a decimal form. So what's that answer? 88 and 4 tenths. Alright, let's go back and look at our actual answer. Let's make sure it makes sense. Make sure it's reasonable. This is 26 multiplied by 3.4. So let's round this. That's about what? That's about 3. And we can round this to the nearest 10. That's about what? 30. What's 30 times 3? 90. That means my answer should be about what? 90. So is it reasonable that my answer is 88.4? Yes. So I'm going to write this up here at the side. I'm going to just say that is about 30 times 3, which means my answer should be about 90. And that way we know for a fact that our answer is what? Reasonable. Because if I had just left it at just 884, would that have been right? No, because my answer should have been about 90. Alright? Which one is more reasonable? 884 or 88.4? 88.4. Any questions about this? No. What do we gotta remember? The placeholder. What else? How? We have to remember the value, the unit form, the value of what we're multiplying. So if I'm multiplying tenths times, and that's 26 what? 26 what? 26 ones. Anything multiplied by ones means I'm ending up back in that place value of tens. Okay? What about multiplying that by tens? Will my answer end up in the tens place? What's tens times tens? Ones. If I'm in the tens place and I multiply that by 10, it's taking a shift to the left one time, which means I'm ending up in the ones, right? That's going to be real beneficial when we start multiplying these fractions by, decimals by decimals. Alright, let's look at the next one. Let's skip around. Let's go to number 7. Let's go to number 7. Number 7 has 2 and 4800 times 35. And then they have it written on the side as what? 248 hundredths. Multiplied by what? 35, right? And it's long, and I'm gonna just write down here to remind myself that my answer has to be what? Hundreds. So a lot of times I like to go in and just remind myself by writing it at the bottom to remind whatever answer that I have, it needs to end up in the hundreds place. So now we do what? Go in and multiply. So go in and multiply. Joshua, Lindsay, Dylan, Trayson, Jacqueline, Derek, Crumble. I'm no calculators. I'm not going to fucking do it. That's how my calculator use people, right?
Yeah.
Because Cooper not. So that 5 times 8 will give us 40. 5 times 4. 20 plus the 4 we got?
24.
5 times 2.
10.
Plus the 2 more.
12.
Remind myself to do it?
Put that placeholder.
With the placeholder. 3 times 8.
3 times 8 is
24. Here the 2. 3 times 4. 12 plus that 2 more. 14. And then the 3 times 2.
6.
Plus 1 more.
7.
And what I'm going to do? Add your partial product. 0 and 0. 4 and 4.
8.
4 and 2.
6.
7 and 1.
8.
That's it? I
I
gotta change this to be what?
100.
So that means that my answer should be 86 and 800. That's our final answer. So let's go back and look at it. 2 and 4800 is about what? It's about 2. Let's just say it's about 2, because it's less than 2.5, right? And then 35 is about what?
40.
We'll say 40. What's 40 times 2? 80. That means that my answer should be about 80. That makes sense, right?
Yeah, I think it goes over 80.
Huh?
I think it goes over 80.
As long as it's around 80. So as long as this didn't end up being 868. So when we round, that's to tell us where my decimal belongs, right? So long as I don't have 8.680 or 868.0, as long as I'm ending really close or around my estimation, I know that my decimal's in the right place. Okay? That's to tell us where my decimal should go. Making sure that my answer is reasonable.